So I've started the recording now. All right, so the topic of today's lecture is streams. Well, basically it's streams, redirection, and piping. Let's see. All right, so in Unix and by extension Linux, a stream or a data stream is just an ordered sequence of bytes. So it's just you can think of it as a what's the best way to think of it? You can think of it as a constant stream of information. Not necessarily constant. It might stop at some point in time. So programs can read a stream, and programs can write to a stream. So on Unix, there are Unix and Unix-like systems. So like Linux and Mac OS, there are 3 standard streams. Right? So there's something called the standard input stream. So that's where a program can read data from. Right? Standard input is normally connected to the keyboard by default. So if you have a computer that happens to have a keyboard attached to it, right? Not every computer does, right? So you can have like these little embedded devices that don't have keyboard input. But if it has one, then standard input normally comes from the keyboard. Standard output is just a stream where output data can be written to. Right? Now, if you have a computer that's got a monitor and it's a Unix-like system, then standard output is normally connected to the terminal by default. Right? So an example of both of those two things are, for example, this is my Linux console. So if I type something, right, that's coming from standard input. Right? When I output something, so for example, print the contents of the file called unsorted.txt, right? That's going to standard output, right? The screen, my terminal, sorry, the terminal. Now, there's one other standard stream, which is called standard error. So standard error is a stream to which error or diagnostic output can be written. Now, again, if you have you're working on a Unix-like system and you've got a terminal, then standard error is also connected to the terminal. So for example, we know the ls command, right? So ls lists the contents of a directory. When I ran ls just a second ago, right, that sent its output to standard out, right? Now, if I make a mistake when I use ls, so for example, if I try to list information about a file that doesn't exist, right? So some file that does not exist. If I do that, then I get an error message. Right? That error message was actually sent to something called standard error. It just happens to be the case that standard error is also connected to the terminal. Right? So even though they look like they're the same thing, they're actually different. Right? So standard. So there are 2 streams that can accept output. And they're actually different streams. So every stream has a unique integer identifier called a file descriptor. Right. So it's so the standard streams have the descriptors 0, 1, and 2. Right. So 0 is standard in, 1 is standard out, and 2 is standard error. Right. You can have many other file descriptors. Right. So these just happened. The standard streams just happen to have the first 3. So 0, 1, and 2, right? So keep those in mind. Redirection. So they're, well, I'm just going to skip this slide. I'm not sure why I have this slide here anymore. I'm going to show you how to redirect a stream. So I can take, for example, I can send, instead of sending something to standard output, I can send it to standard error. Instead of sending something to standard error, I can send it to standard out. Right? And instead of doing either, I can, for example, write it to a file. Right? So I can redirect where the output goes. Now, in Linux, commands, you can think of them as being similar to segments of a pipe. Right? So here I've got a picture of a pipe. Right? You know that pipes normally contain stuff, right? So water or oil or gas or something like that. Right? And so stuff comes into the pipe at one end and it comes out at the other end. So input flows, right? So input comes in, output comes out, right? And you can think of a command as being analogous to a pipe, a segment of pipe, right? So I can feed inputs to a command, and the command can produce some output. So for example, the command ls, right? I can give it a command line argument, right? So for example, I can give it the command line argument /bin, right? And so that tells ls to list the contents of the directory /bin. Right? So our input is our command line argument. Right? So that comes into ls, and ls generates some output. Example. Right? So if I do ls/bin, right? The input is /bin, the output is all of that. So it generates quite a lot of output because on my computer there happens to be a lot of files in root bin. Now, command input can come from standard input for some commands, right? So the last one was taking it from the command line, right? But there are some programs where when you run the command, the command will actually wait until the user enters some input, right? And if you're typing it in, then that input comes from standard in, right? So sort is a command that will sort. We'll do line-by-line sorting of its input. Right. So if I just type the command sort and then press enter, right, you can see that nothing seems to happen. So you just get this blinking cursor here, and that's indicating to you that sort is actually waiting for some input. So if I type this stuff over here, right, so zebra, enter, elephant, enter, anteater, enter, and then dog. So if I type that in, this becomes input to the command sort. Now remember, sort is reading a stream, so it's reading standard input. Right? So I need some way to indicate to sort that this is the end of the input that I want to provide. Right? So Control D signifies the end of input. Right? So this basically says this is the end of the stream. This is the end of the data that's sitting on standard in. So if I type Control D, on Mac it's probably Command D, but I'm not 100% sure. But it's probably Command D. So if I press Control D, right, sort now goes to work, right, and it sorts its input, right, line by line. So by default, it's going to use alphabetic sorting, right? So anteater comes first, right? So the output's actually here: anteater, dog, elephant, zebra. Still Control D. Okay, thanks, Akash. It's Control D, I guess. Right. So it sorts the input line by line and gives you anteater, dog, elephant, and zebra. CISC is another program that can take its input from standard in. Right. So if I want to, normally we do something like CISC and then provide a command line argument. Right. So we do something like this, right, and it prints its command line argument, right, using some sort of animal. Right. But you can also run CISC and have CISC read standard input. Right. So if I type CISC and press enter, the program will now wait until the user inputs something onto standard input. So I can type hello, and then enter, and then world, and then enter, and then right, press enter, right, and then when I press Control D to indicate that standard input, this is the end of standard in, right, then the program actually runs and generates its output, right, so it sends its output to standard out. For many Unix/Linux commands, right, like sort, output goes to standard out, right? So a program that generates output usually sends the output to standard output, right? Unless you give it some command line option that says otherwise. So when you run sort, it prints out the list of sorted, in this case, animals. Now, the output of a command will usually go to something called standard error if the command encounters some kind of error, right? So for, again, using that ls example, right? If I try to list information about a file that doesn't exist, then you get this error message like this. So, right? You get that message there. Now that looks like it went to standard output, but in fact it went to standard error. Okay, now I can change where the command gets its input from or sends its output to. Right? So the process of changing where input comes from or output goes to is called redirection. So if I redirect standard output or standard error, right, I can send the output of a command to some other stream. So for example, I can send it to a file instead of printing it to the screen. Right? If I redirect standard input, then that changes where a command gets its input from. Right? So for example, I can have a command get its input from a file by redirecting the file to the command. So to redirect standard output, right? So for example, I want to take the output of a program, and instead of printing it to the screen, I'd like to save it to a file, right? Then you use 1 and then the greater than symbol, and then the name of the file where you want to send the output to, right? So the 1 means, remember 1, that's the file descriptor. So remember 1 is the file descriptor for standard output, right? The greater than sign, that's the output redirection, right? So operator. Now, if this file doesn't exist, then the redirection will automatically create the file, right? If the file already exists, then the redirection will overwrite the contents of the file. So if you have a file, if you already have an existing file, then redirecting to that file will blow over the contents of the existing file. So you have to be a little bit careful about this if you're doing this, right? So you want to make sure if there's an important file that you don't want to overwrite, you have to make sure not to redirect output to that file. So for example, I would like to list all the contents in my directory, right? I don't want to list those two directories. Now remember, dot is the current directory, right? Dot dot is the parent directory, right? I want to redirect all the listing of the files to this file called files.txt. So let's just do ls first, right? So that's what ls does, right? ls minus big A. This is going to list all the hidden files as well, right? So you see all my dot files, right? So dot something indicates a hidden file. If I do ls minus little a, right, that's almost the same as big A, except you'll see that ls minus little a also prints also prints out the two hidden files dot and dot dot, right? So remember, dot is just the current, it means the current directory. Dot dot means the parent directory, right? So it turns out in every directory those files exist, right? So there's a file that corresponds to the current directory. There's a file that points to the directory immediately above. Okay, so instead of sending it to the screen, let me send it to a file, right? So I'm going to use redirect everything to something called files.txt. Right? Now, when you do the redirection, right, nothing gets printed, right? Because I'm sending the results. I'm sending the. I'm saying take everything that would normally go to standard out, and instead send it to that file. Right? Now you can check that it actually went to that file by using the command called cat. Right? So I'm going to use cat files.txt. Now cat will output the contents of the file, right, to standard output. It'll actually do more than that, but this is the easy way to look at a file, right? A text file, right? And so you can see when I look at the output of cat that the contents of my file, files.txt, is actually just a listing of all the files. Right, now also notice that it doesn't appear the same way that it appears up here. Right, so when so ls minus a, it will print things out in columns. Right, but when you redirect it to a file, everything shows up in a single column. Okay. Okay, so redirecting standard output is quite common. So it turns out that when you're working in Linux or Unix, you don't actually want to see everything pop out onto the screen, right? Instead, you want to save the result to a file so that you can use the result somewhere else, right? So it turns out that redirecting standard output is more common than redirecting standard error, right? So normally when you run a command, you want to avoid getting errors, right? That seems pretty obvious, right? So when you do redirection, you can leave off the 1. So if you leave off the 1, then the redirection automatically redirects standard output instead of standard error. Right? So instead of writing ls minus a 1 greater than files text, you can just write ls minus a greater than files text, right? And that'll do the exact same thing. Any command that sends its output to standard output can have its output redirected to a file. Right? So CISC sends its output to standard out. Right? If I want to, oops, sorry, I can, instead of sending it to standard output, I can redirect the results of CISC to a file. So this is going to use a dragon to print out as a picture. So if I don't redirect, oops, sorry. If I just run the program on its own, right, the result gets sent to standard out. If I instead redirect the output to a file, nothing gets printed, right? Because I've sent the outputs to a file instead. If you want to see the file, you can just add cat, and there it is. If you want to, if you don't want to overwrite the file, right? So what does minus F do? So for the CISC program, minus F cal file. So the CISC manual is actually not written very well, but that's because it's just a silly program, right? So whoever wrote the manual didn't spend that much time on it. Let's see. So there are, so you have to sift through, here it is, the documentation. So the minus F option specifies a particular cal picture file to use. Right. So so you can change the I guess the animal or the picture that's used by the CISC program. Right. So if you do CISC minus L, lowercase l, that tells you that gives you a listing of all of the shapes that you can feed, that you can use for minus F. Right, so if I do CISC minus F moose, that'll use a moose instead. Right, so that's all. That's all minus F does. It just changes the shape that's used to the shape of the animal or whatever that's used to print the message. If you want to redirect the output to a file, but you don't want to overwrite the file, right? So instead, if you want to add to the end of the file, it's the double greater than sign. First of all, oops, sorry, files. Okay, so that's the contents of files.txt right now, right? If I rerun the ls command, and use the redirection operator that appends, right? I can, like that, right? Then I should get 2 copies of all of this, right? So I should get this followed by all of that again. So if I do cat files.txt, right, now you can see, right? So there's, starting here, right? There's the result of the first time I ran ls-a, and now here's the result the second time that I ran ls-a, right? So the double greater than sign will append to the output file instead of overwriting. Now, if you want to redirect standard error, and often you do, then that requires, or sometimes you do, sorry, then now you have to use the file descriptor for standard error, right? So ls/bin-z, right, asks ls to print information about this file, right? B2 greater than means if there's any output sent to standard error, redirect that to error.txt, right, and save that in that file. So this should produce an error because there is no file called bin-z, right? Right, so you get some sort of error message. If I redirect standard error to error.txt, right, notice that there's no error message now, right? So it's not printed to the screen. Instead, whatever got printed to the screen went to error.txt, right? So if I cat the contents of error.txt, right, you see the error message now. Right? So this is useful if you're writing a program and you want to not have your error messages pollute the output screen. Right? So sometimes you end up doing this. And you can redirect both streams at the same time, right? So I can redirect. So if I run the ls command, so if I ask it to list the contents of bin and then ask it to print some information about the file bin-z, right? ls actually sends output to 2 different streams, right? So it sends whatever, it sends the contents of the directory bin to standard out, right? Because that's because there is a directory called root bin, and then it sends the error message to standard error. Right? So if I just ran that command on its own, so ls root bin and then bin-z, it's going to print out everything that's in bin. So there you go. Right, but it also prints out an error message saying, here we go, right, saying it can't access bin-z, right? There's no such file in the directory. Right now, I can redirect the output of ls. I can redirect. Sorry, I can redirect. What's going on here? Oh, wrong button. Sorry. I can redirect the standard output to files.txt or any other file that I want, right? And I can redirect the error message to error.txt, right? And now nothing's printed, right? But if I look at what's in error.txt, right, there's the error message, right? And if I look at what's inside files.txt, right, there's a listing of all the files, right? And it's quite long. So you can redirect both streams at the same time, right? If you want to, you can redirect standard input as well. So you can redirect as many streams as you like. Okay, now if you need to redirect standard input, then you can do it using the less than sign, right? So 0 less than input file, right? So that will redirect the contents of that file and send that to the input of a command. Right? So if you have a command that does not accept the file as input, right, you can make it accept the file as input by redirecting the contents of the file, right, using less than. Right, 0 is the file descriptor again, right? So like the redirecting standard output, you can leave the 0 off because there's only one standard input. I think you can anyway. Now, most commands already accept files as inputs, right? So normally you don't have to do this. but you can always check the man page to find out if you do. Right? But you can still use redirection if you want to. Right? So the sort command that I showed you earlier, I can redirect the contents of unsorted.txt to standard input for sort. Right? So let's take a look. I think I have unsorted. Yeah, so there's the contents of unsorted.txt. Right? Now, if I type sort 0, I'm pretty sure you can leave the 0 off unsorted.txt. Right? We'll take the contents of unsorted.txt. Right? Send that to standard input. Right? And redirect that to the program sort. Right? So now you see sort takes the contents of that file and prints out the sorted version of that file, right? Line by line. What was I gonna say? There was something I meant to say. Oh, right. I wanted to look at the man page for sort. So you normally don't have to do this because commands like sort, right? When you read the man page, it already tells you that sort will accept the file natively, right? If you read the description, it says write the sorted concatenation of all files to standard output. Right. So what that's trying to tell you is if you specify more than one file, it will sort the first file, write it to standard output. It'll sort the second file, write it to standard output. It'll sort the third file, write it to standard output. And now it also tells you if there is no file, or when file is the hyphen, it will read standard input. Right. So quit. Right. So earlier, when I just typed in sort and pressed enter, right, because you didn't give it any files for input, it's going to read standard input now, right? So that's when you can do something like this and then press Control D and get that. Right. So most commands already accept files as inputs anyway. So normally you don't redirect. Normally you don't have to redirect standard input. Right. It is useful though for the small set of commands where you don't that don't accept a file as standard input, a file, sorry, as input. Right. So for example, when you, later on when you write your own C programs, it might be the case that when you write your C program, it doesn't accept the file as input. Right. So instead, it wants to read standard input and do something with it. Right. You can still use your program from the command line to do something with a file instead by redirecting the contents of the file. There you go. So the file descriptor is optional for input redirection because there's only one standard input anyway. And again, you can redirect both the input and the output if you like, right? You can redirect the input, the output, and the error stream all at the same time, right? So here, I'm going to take the contents of unsorted.txt, right? Redirect the contents to the input of sort, and take the output of sort and send it to sorted.txt, right? And that works if you type that in, right? It does exactly what you think, right? Takes the unsorted file, sorts it using sort, saves the results in the file called sorted.txt. Okay, now instead of redirecting the inputs and outputs, or instead of redirecting standard in, standard out, and standard error, right? You can hook commands up into a pipeline, right? So I've already shown you this a little bit already. So I can take the output of a command, right, and hook that up to the input of another command. For example, like this. So I can take the command ls, right? I can ask it to list the contents of the directory bin, right? And then instead of having an output here, right? So instead of sending the output to standard out, I can immediately pipe the output to the command called less, right? And less will send its output to standard out, right? So for example, so ls root bin, right? So you know that spits out a whole bunch of stuff, right? Instead of scrolling manually after the command runs, right? I can take the output of ls bin and pipe that to the command less, Now remember, less is just the program that is used to display man pages, right? But it will also display any file, right? So now, right, when I list the contents of root bin, right, it doesn't spit them all out into all at once, right? It sends it to the program less, and less prints things out one page at a time, right? So I can go forward a page, right? I can go backwards now as well, right? So forwards, forwards, forwards. B is back a whole page, right? And so on. That's handy, right? You can build very complicated commands, right, by assembling lots of smaller commands into a pipeline. So I've shown you fortune and CISC before, right? So fortune is a program that prints a random fortune to standard out, right? Instead of sending it to standard out, I can pipe the output of fortune directly into CISC, right? And then CISC will will then send its output to standard out. Okay, so again, just to remind you what that looks like, right? So fortune prints a random fortune. Right? If I instead pipe the output of fortune to CISC, right, that will use the CISC program to print the fortune. Right? Trouble day for I don't know what that means. Anyway, and you can connect as many commands as you like. Right? So as long as a command sends something to standard out, right, you can hook it up to the standard. You can hook it up to the input of another command. Right. So I can take the contents, I can ask ls to list the contents of bin and user bin, and then send that to sort. Right. So sort them alphabetically. So this is going to list the contents of two different directories. Right. Normally it would list the contents of bin, then it would list the contents of user bin. Instead, I'm going to send all of that to sort. So that's going to sort everything. Right? And then I'm going to send that to less. Now on my computer, bin and user bin, it turns out they're the same directory. If I do ls bin, and if I do ls user bin, it's the same output. So basically when I do this, when I do ls bin user bin, I'm going to get output, I'm going to get 2 copies of the same thing. Right. So there you go. You can see there's a lot of stuff. Right. The only difference is when I get to the top here, where'd it go? Somewhere, I probably missed it. Hang on, let's see. Somewhere it's going to print out bin colon, and then it'll print out user bin colon, and then list the contents. Right. Now I'm going to, oh, sorry, hang on, where are we? I got to go to my, I have to find my prompt again. There we go. Okay, so ls bin and ls user bin, and now I'm going to send, sorry, send the output of that command to sort. Right. You can see now there's 2 copies of everything, right? Because again, because bin and user bin are actually the same directory on this computer, right? And if I want to, I can send that to less. Right. Again, oh, here's what I meant, right? So here you see /bin, and here you see /user bin now, right? And there's just 2 copies of every file. So I can do that. Instead of printing, or instead of using less to display the contents of both directories, I can send the output of sort to this program called WC. So first of all, let's look at what WC does. So WC, print new line word and byte counts for each file. So WC is word count, right? So you can find the number of words in a file, you can find the number of new line characters in a file, or you can find the number of bytes in a file, right? If you want. So you just pass in a different flag. I think by default, you get the number of, is it by number of lines? Print a word with no file, reach the output. I'm going to use -L to get the number of lines. So if I use this command here, instead of sending it to less, I'm going to send it to word count. Why don't we just send it to word count and see what we get? Okay, there you go. So This is the number of new lines, words, and byte. Okay, so that's what it's giving you. Okay. So that's the number of new lines, characters. That's the number of lines. That's the number of bytes. I want the number of lines that are output. It says that there's 2,289 lines, 89 lines output, right? Which means there's roughly 1,100 files in bin and or user bin, right? So there's a lot of commands in those files, in those two directories. I want to get the number of unique files, right? So remember when the files here are the same as the files here, right? So if I want to find the number of unique files, I can use this command called unique. Look at what unique does. So unique will tell you, so report or omit repeated lines. Right? So it will filter adjacent matching lines from input, writing to output. Right? So input's normally standard in, output's normally standard out. Right? So what that means is, so this is sorted, right? So unique will go line by line, and if it sees two lines that are the same thing, it will remove. It will only print out the thing once, right? So instead of writing bin user bin nf, it's going to write bin user bin nf, right? And then it sees two copies of VG auth service, so it'll only print out one, right? And then so on and so on and so on, right? So for unique to work properly, your file has to be sorted, which is why I use the sort program before sending it to unique. So let's do this. So send the output of sorts to unique, and now I'm going to send the output to less. Right. And now you can see that I only get one copy of every file printed. Right. Now, if I count the number of words, the number of lines, sorry, that's the number of unique files that are in user bin and bin. Right. So there's roughly 1,100 commands or 1,100 files in either one of those directories. If I want, I can count how many duplicated files there are in the two directories. Right. So I think you can start to see that using the commands in Linux, it's all about reading the man page and understanding what the commands do. Either reading the man page or looking up the documentation for it online. Right. That tells me there are 1,143 duplicated file names in the output from here. All right, so that's redirecting and pipelines. Now, there's something called a T, right? So redirection allows you to send the output of a command to a file, right? So I can redirect the output, standard output, and send it to a file, right? Now that's a little bit different than piping, right? So piping will let me take the output of a command and send it to the input of another command. Right? Now, there are situations where you want to do both, right? So if I pipe the output of a command to another command, I can't see the output, right? The output doesn't appear on the screen, right? Similarly, I can't pipe the output of a command to another command and redirect the output of the first command to a file at the same time, right? Not using just the pipe, right? So if I want to do both, I have to do something else, right? So the way to do something else, or the way to capture, right, to redirect the contents of this command to a file, is to use what's called a T, right? So T is itself a command, right? But the only thing it does is it redirects its output to some file, and it sends on its output to standard out as well, right? So if I have some command here that produces some output, and I want to save its output, right? But I also want to send its output to another command, then that's when you use a T, right? So the output from here gets sent to a file, but it also gets sent on to the next command. Okay, so that's what a T is for. So the T command is useful for saving the intermediate results of a pipeline to a file or files. Right, so you're allowed to use as many T's as you like. Right, so I can use command T, command T, command T, and so on and so on and so on. Right. In this example here, I'm going to use the date command to print the current time. Right, and I'm going to use T to redirect the original output to a file before passing it on to another program. So date. Remember, date prints out the current date in the current locale, right? So we're in Eastern Standard Time, so it prints out the date and time in Eastern Standard Time. Right. Now, if I want to redirect the time to a file, right? I can do it like this. That doesn't let me see the output. Instead, I have to then print the contents of the file. Right. So if I want to see the output and save the contents to a file, I use a T. Right. So I pipe to the program T. Right. T will send its output to the date.txt. Right. And it will also send another copy of the output to standard out. Right. So now I can see the output. And if I want to, right, I can. So I can see the output, and it redirects the results to the file date.txt. Right. So what else do we want here? So that's the full date. I'm now going to send. Right. So I'm going to save the output of date to full date, but I'm also going to send that output along to this program called cut. Okay, so let's take a look at this, see what it does. So I'm going to do date pipe to T. I guess we'll just do the what the slide actually says. Cut equals this. So I'm going to do that. Right. Let's just look at the output. Right. So you can see that cut is going to only print out the day. Right. So the date. Right. That's what it actually is. Right. Pipe that to T. So I'm going to save that date to full date.txt. Right. But I'm also going to take that output, send it to cut. Now cut is going to take this and chop it up into spaces. Right. So everywhere there's a space, right, cut is going to split the output at the spaces. Right. And then I'm going to ask for the first field. Right. So when it cuts it up, these are the results are called the fields. Right. So there's field 1, January is field 2, 18 is field 3. That's field 4, that's 5, and that's 6. Right. So I'm going to ask for the field 1, and then, so that gives me Tuesday. Right. If I ask for field 2, that's going to give me January, and if I ask for field 6, that should give me the year 2022. Right. But in all of these cases, full date is always the original output from date. All right. Now you can chain calls to cut. Right. So I can cut, ask for multiple fields, and then pass it again and cut again. Oops, sorry, that's it. All right. So that's redirection, pipelining, and T. That's how to use redirection, piping, and T from the command line. Any questions about the contents of today's lecture? In the next lecture, I'm going to tell you how to actually manipulate files. Right, so there's actually quite a lot of stuff today. There's a bunch of commands that were introduced, right? So sort, unique, word count, WC, cut, date, and T. Those are all commands, right? You should be able to redirect output of a command to a file, right? You should know how to redirect the contents of a file to the input of a command, right? And you should know how to chain together basic commands using a pipe, using pipelining. Right. Some of these commands don't translate exactly. Date won't translate exactly. Date version of date is definitely different on Mac. How do you know what to change? So a lot of these, like things like date, aren't especially important. All of the important commands that we use in the course, they work more or less the same, right? So things like ls, how to copy a file, how to move a file, and things like that, those all work exactly the same. The ones that are different tend not to be that important for this course. All right. Any other questions? All right, I'm not seeing anything. So I'll end things there. And I will see you